Hello everyone, this is day number 1, the probability and statistics chapter focused on central tendencies, quartile stuff, and so on. So without any further ado, whatever, let's get started. All right, some statistical terminology that I'd like to highlight here. If we're dealing with a population as opposed to a sample, so a population here is the total set of all data. You'll notice that we use Greek symbols for the mean, variance, and standard deviation, whereas with a sample, which is a subset of the total population, we use kind of your normal English language letters. This one here is X bar, that's the sample mean. Here we've got S squared, which is the sample variance, and the standard deviation, which is S. We'll talk about how to calculate those in just a moment here. So a population mean and a sample mean have different symbols, one being mu, the other one being X bar, but both are calculated the exact same way. And this sigma notation here represents, we are going to, using the sigma, add up all of the X values, or all of the values in the set, and then divide by the number of terms n in the set, number of terms. So if we look at this set of data, I don't know if this is a population or a sample of the population. It doesn't really matter. What I'm going to do is I'm going to take 2 and 5 and 7 and 9 and 23 and another 23. I'm going to add them up and I'm going to divide by the number of terms, which is 6. And this would give me, of course, if this was a population, this would give me mu. And if it was a sample of the population, we would call that X bar. The mode, as you know, is the most frequently appearing item. So in this case, the mode would be 23. And the median, if we put them in smallest to largest, if we have an even number of numbers, right? For example, this set has 6 numbers. The median will be called Q2, and it'll be the average of the 2 middle numbers. So Q2, or the median, would be 8 here. If we had an odd set of data, let's say we added a 7th data point, 25, then our Q2 would be 9, right? Then it would be the absolute middle number in that set. So depending on even or odd, that's how you'd find the median. All right, so earlier I spoke a little bit about the difference between a population and a sample, and where that comes up is when we're calculating variance and standard deviation. So I didn't mention on the first slide, but when you're talking about population, of course, we would use these Greek symbols. So sigma squared is the variance. And in a population, you have n degrees of freedom. Okay, in a sample, of course, we'd be talking about S squared, and you have n minus 1 degrees of freedom. So you'll notice that here, this is going to be my variance, and here, of course, is the standard deviation, which is the square root of the variance. Something to notice that I'm taking each of my X values, subtracting the mean, squaring those, adding them all up, and dividing by n, which is the number of terms in the set. So this is where that degrees of freedom comes into play. So again, I'd take this value, if I wanted the standard deviation, I'd take this summation, add them all up, take its square root, and that would give me the standard deviation, again with n degrees of freedom. If we're talking about a sample, right, then I would have S squared, and I'd add up all the X, or take all the X values, subtract the mean, which is still X bar. It's just a different variable that we use to note to the user that, hey, you're working with a sample. Square them, add them up, and now you divide by, check out the degrees of freedom here, n minus 1. So if the set had 20 data points, you would divide by 19. And of course, this would be the standard deviation, S, by taking the square root of the variance. Okay, a little side note item here in this lesson is something called the cumulative frequency table. It's one of the tables that's used to display data, and basically how it works is, let's say that a teacher gives an 11 problem test or quiz, and 9 people take that test or quiz. So the number of people here, it looks like they've got 0 or up to 2 right was 1. The number of people that got 3 to 5 right was 2. The number of people that got 6 to 8 right, 4, and 9 to 11 questions right was 2. So the way this cumulative frequency table works is we accumulate totals in that third column. So one person total, then we would have 2 more, which would make 3 people, which gives us an idea of how many people got less than or equal to that number of problems, right? Another 4 people added in the next score row, and then 2 more. So what you'll notice is that your last data point in the cumulative frequency table will give you the total number, right? Total number of people involved or items involved in the data set. So as we plot the cumulative frequency, notice that the average score of each of the intervals is located here on the independent axis, and then the frequency or the cumulative frequency along the dependent axis. So one person got between 0 and 2, so I would put a point right here representing that one person was in that interval of problems correct. Then we would go up to 3 there, and then up to 7 for the fourth. Up to 7 on that one, so that would put us here, and then up to 9 in that next interval. And this kind of looks linear, but it won't always. So basically what you can do is you can say, one way you can use this is, since I know there are 9 total people, I could say that, generally speaking, that looks like about 50%, right? This difference here is 4 people, give or take. About 50% of people got between a 4 and a 7 on this. Okay, which is, roughly speaking, on a small data set like this, not entirely accurate, but the larger the data set, the better the estimate. Okay, this is a cumulative frequency table used often to display data in such a way that you could make generalizations. All right, quartiles. First thing you want to do when you're calculating quartiles, which are Q1, Q2, Q3, you want to put the data sets the data in order from smallest to largest. Okay, figure out how many points there are. It looks like I've got 9 items here, so n equals 9. With an odd data set like that, you find the middle number, right? That's Q2. So it looks like Q2 here is 11. Now I take my lower end, and to get Q1, since I'll have an even number of numbers, I'm going to average these 2 numbers, 3 and 6. So that'll be 4.5. That'll be Q1. And then on the upper half, again, I do the same thing. I average these 2 numbers. That gives me 22. So Q3 is 22. This spot right here is my min value, which looks like it's a 2. And my max value, which looks like it's a 26. Okay, there is this thing called the IQR, interquartile range, and it's always Q3 minus Q1. It gives you an idea of that middle 50%. All right, so in this case it'd be 22 minus 4.5. So our IQR would be, what is that, 17.5? So a range of 17.5, whatever it might be, points or whatever the maybe inches, if these were measurements, who knows, right? So within the min to, oh, that was really good. Within the minimum to Q1, we would consider 25%. Same thing there from Q1 to Q2, there from Q2 to Q3, and then from Q3 to the max, all being approximately 25% of the data. Just another way to display that data. All right, so let's do some examples here. Really fun kind of puzzle type examples. I'm going to quick draw out or sketch out the meaning of what, that's funny, what the mean looks like here, and then I'll be right back. All right, so I've added up all my points divided by 6 since there are 6 of them, and that tells me that my mean is 6. So what I can say is that 4 plus 6 plus 9 plus 3 plus, oh, you know, something's going on here. Let's try that again. Plus A plus B is equal to 36. All right, so I can say that A plus B is equal to, oh boy, what is this? That's 10, 12, 22. So A plus B should equal 12. Now, if the mode of the data set is 6, and I know A is greater than B, like, sure, I could say that A and B are 6, but since A is greater than B, I know that A and B can't be equal. Okay, so what I can say then is, I'm going to take, let's see here, let me take, oops, I want an eraser. Where's the eraser? I don't know where the eraser is. Okay, forget it. I can say, okay, let's take this 12 plus A plus B has to equal 36. All right, so I know if I want the mode to be 6, that means either A has to be 6 or B has to be 6. I'm going to take a guess and say A equals 6. So then if A equals 6, then 12 plus 6 plus B equals 36. That means 18 plus B had to equal 36. Oh, wow, yeah, that's way off. Way off, holy cow. I just said that this equals 12, which is totally untrue. How about plus 10? Cool, plus 10. So that means plus 10. All right, so that means 28 plus B equals 36. That would mean B would have to equal 8. So if A equals 6, then B equals 8. Well, I know one of them has to equal 6, but since A has to be greater than B, that means I have to flip-flop these two. So A will equal 8, and B will equal 6, and that will guarantee that the set has a mean of 6 and a mode of 6 as well. Well, you know, sometimes you just pick wrong, and you just got to live with it. All right, let's try another cool one. This one says apparently 2 minutes. I don't know if that's true. We'll see. The following items have a mean of 6. How many items are there? 1, 2, 3, 4, 5, 6, 7, 8 of them. So 2 plus 5 plus, let's go 3Ks plus 3 plus 7 plus 4 over, how many was that? 8 equals 6. So if I divide that by 8, that equals 6. But if I multiply both sides by 8, so if I divide by 8, that equals 6. Therefore, if I multiply both sides by 8, that equals 48. Oh, okay, we can find K pretty easily here. So this will be 7. This will be 14. So 3K plus 21 equals 48. I can do this, I think. Subtract 21, that's 27. Looks like K has to equal 9. These are so much fun. I hope you're enjoying it as much as I am. Okay, so if A plus B plus C plus D has a mean of 8, then that means A plus B plus C plus D plus E equals 40. So A plus B plus C plus D plus E over 5 is 8. Multiplying both sides by 5, I get 40. So find the mean of the following: 10 minus A, 10 minus B, 20 minus C, 20 minus D, and 50 minus E. Watch what I'll do here. This is kind of cool. 10 plus 10 plus 20 plus 20 plus 50 minus A plus B plus C plus D plus E. Okay, I want to find the mean of that. Okay, now if I want to find the mean of that, I'm going to divide that by 5, and that'll be the mean. Let's say this is, I don't know, some kind of, we'll just say it's the sample, right? Because let's say we don't know all the terms, okay? But what I do know, and I can calculate this relatively quickly, is that's 40. So 10 plus 20 plus 20 plus 20 plus 50 is what, 110? I think 20 is 60, yeah, 110 minus 40 over 5. That's going to be our mean. Again, I'm under the assumption that this is a sample, not the population. So that would be 70 over 5, which is 14. Cool. Okay, last problem that I want to do for today. And this is kind of intimidating, but it's actually not quite as bad as you'd think. Okay, so I want to find the variance of this data set. And the variance, you guys, sigma squared of this data set is going to be equal to, and I've proved this in a different video, but it's going to be equal to the expected value of x squared, right? Which is just, in other terms, that's the mean of the x squareds. So if I took each of the terms, squared them, divided it by the number of terms, that's the expected value of x squared, right? Which is closely related to this. That's the sum of the x squareds. So to turn what's here into this, I just divide it by 20. Okay, and then I'm going to subtract the expected value of x, quantity squared, which in mu form is the mean squared. So sigma squared is equal to the expected value of x squared, or mean of the x squareds, minus the mean of the x's squared. So I have the mean of the x's, it's 11, and I can find the mean of the x squareds by dividing this 2872 by 20. When I take 2872 and I divide by 20, I get, 143.6. And when I square 11, I get 121. So the variance of this data set, I can't do math apparently, is 22.6. If I wanted the standard deviation of the data set, I just take the square root of that, which I don't know what that is, but it's a little less than 5, I think. So there you have it, you guys. That's variance, mean, some standard deviation, a little bit of cumulative frequency, and some centers of spread. All right, have a great day. We'll see you next time.